All right, let's look at spectroscopic parallax. First of all, spectroscopic parallax is not real parallax. It's not the way that you measure distances using angles and stuff like that. It's just a different way of getting at the distance to a star. So the idea is this, that if you know what the brightness of a star is, the luminosity of it, the intrinsic brightness of it, then we can also look at how bright it appears, what its apparent magnitude is, plug those into our distance modulus calculation, and determine how far away the star is. So what you have to do then is figure out what the spectrum is, take a spectrum of it, figure out what type of star it is, whether it's a G2 or an F8 or whatever it is, and then you'll have located it on the thing here, and you can use this calculator to figure out what the distance is. So let's do an example. Let's say that we had, let's just say it's a type A9, okay, right there. So A9, you see I move this back and forth, it changes what the temperature is on the little diagram there. So let's say it's an A9, okay. And we know that because there are moderate hydrogen and strong ionized metal lines, and the spectrum looks like this. Furthermore, we know that it's a main sequence star, which is the little V in the lower right here, because the lines have a certain sharpness to them. If they were one of these, they'd be even sharper, and we'd know it was a giant, but because they're a little bit fuzzy, we think it's a main sequence star. So let's say we know that. Then we can figure that we know what the luminosity of the star is, right? So the luminosity of the star is actually a magnitude 3, okay? So if it was at a distance of 10 parsecs, it would be magnitude 3. The apparent magnitude is 10.8, let's say. And so we just figure, okay, that's an A9, and it must be have an actual magnitude of 3. And so then we just plug that in here, and we have 10.8 minus 3, and that is equal to 366 parsecs away. So if it were a brighter star, let's say it was here, like a B4 star, then its apparent magnitude was 10.8, then it would be even farther away. If it was a dimmer star, let's say it was only a M4, and so that would be a red dwarf, that would be a very, very dim star, but its apparent magnitude was still 10.8, then it would be at a distance of only 3.58 parsecs away, which would be pretty close to us. So all you have to do to find the distance using the spectroscopic parallax is determine what type of star it is, determine from that, from the main sequence, what the luminosity of that star is, plug the apparent magnitude, which you can get from just measuring the magnitude of the star in the sky from Earth, into the equation, and you'll get the distance coming right out at the end.